into the introduction to TIA Portal, the program that we are going to use to design or to program our PLC. This is a follow-up on the introduction to PLC that we had. So this video, we are only going to do the introduction of the PLC TIA Portal, so that you will see how to operate the software, where can you find your modules, your component, and how to write a program, but not to simulate it. We are not going to simulate a program. We are only going to write the program for this video. There will be a video where we'll write a program of the problem that we had in class, where we had a pump and 2 tanks and 3 sensors. We'll have that on a separate video. And then also on another video, we'll have a video that will have your timers, your latches, and the counters, and also and etc. So for today, for this video, we are only an introduction to the software to TIA Portal. This is version 17. You can download this version on a Siemens website. I will share a link, but you must register and download version 17. I will create a link with a separate video on how to download those softwares, but you must know that this is a 21-day license. But for practices purposes and understand what we need to do, it's important to have. This is what you have after you have opened your TIA. This is the page. As I've said, we are using version 17. This is the name of the project. You press create. If you go to here to exit to existing project, you find projects that you have done. Here, this is to create a new project, or if you migrate a project from an older version, you are bringing that project here. So we leave it as it is. We call it project 3. We can leave everything. If you want to change where you want to save your project, in this case I'm saving under control system TIA. Then you press create. Here you'll have to wait a little bit for it to create. What we want to do, we want to create a project. Then from a project we can configure. From configuration, then you can then design a program. So this is the window that you'll have. TIA has made things a bit easier, because as you can see, we have start. It's like they are telling us what are the steps to take for us to have a final product. First one, you have to do a configuration. They call it a configure a device. You must write a PLC program. Then you must simulate, and then if you have included your HMI, then you'll be able to control or to visualize whatever that you need to see and be able to control. So for in our case, what the first step we're going to do, you're going to configure. You click configure a device, then it will show this page. Then you must highlight, you must click here, add a new device. You click add a new device, then automatically and it will open this window. Now this is the controllers. The controllers will have your PLCs. You have your S7 1200, S7 1500. You have your S7 300 and S7 400. So these are the PLC that we have here. It's your HMI. Your HMI, you have your basic control, 3 display, 4 display, and all these options that we have, you'll be able to add as a new project. And then you have your system, your PC system. Your PC system include your embedded system, include your sorry, not embedded system, your embedded controller, and your SCADA, etc., etc. But for our case now, we'll go back to a PLC. We can select a S7 1200. Sorry for that. Then there's CPU. Then from CPU you can choose. We will choose this one. However, for this one, you must use the hardware PLC, the physical PLC that will have and read for these numbers, and then you select exactly the same number as you have on your physical PLC. So we select this one, and then you add the component. After you have added the component, this window will open. Sorry for that, it's the change of season, so my throat is a bit dry. And then we are waiting for a window to open. Now this is a window that is open now, and as we can see, we have our Rexil, and then we have here our PLC. Then when we have our PLC, it's the one that we have selected. It's a compact PLC. It have also input and output modules, or IOs. But if we selected as a PLC that doesn't have your IOs, you go to your hardware category or catalog. Here you have your CPUs. You can add another CPU here. You have your signals ports, you have a communication port, you have your battery port, and you have your digital input, digital output, digital input, digital output, and analog output, analog input, analog output, and then a combination of analog input and output. Let's say we want to take digital input and digital output. You can select here. Again, you can look at your module, then you can select this module, and then you drag and place it here. Then you have your module, your IO module. You can now start to design or to configure, but the first step that you are required to do, you go to PLC. You can go to properties, PLC properties. You can open up here. You can go to general. You can go see all the channels, and you can see the you can see your web servers and all this, and also because this one, it does have IO stack, you can see this is the IOs that are available for us. This is the Q, which is the output. This is the I, which which is the input. And again, on this PLC, let me zoom, we do have it does show us our IOs. And this one, it's our okay, let's start here. This is your IO, this is your I, this is your Q. Input, output, input, output. Input is for our sensors, output is for our actuators. Then you have an internet port Profinet interface, whereby you can connect different PLC. We can connect PLC together using the interface. This is, let us look here. We have our device view, you have our network view, we have our topology view. On our topology view and our network view, you can add another a controller, or you can add, let us add HMI, basic one. Let's say we want Ford display, then go to Ford display. Okay, activate. Then you can take it and put it here. It will take a little bit longer, but I'm just trying to show you what you can do. Then you can connect, as you can have now here, and then we can connect here our PLC with HMI. Okay, let us delete it. Let us go to a device view and look at things that I would say are crucial for our understanding now. While we are waiting, okay, let us zoom here. As we have, these are important because you will have to address your inputs and outputs. This is important so that when you are connecting your hardware, you know exactly where are your input and your sensors and where are your actuators. So now what you need to do after you have configured, we can now start writing the program. We know this is the IOs that are available for us. We are not for now going to discuss this because we are just doing mainly an introduction to this. We don't want to make the video so too long because we want to have videos for each section. Now we have done doing this configuration. Then for us to be able to write our program, we need a main OB1. We double click here, OB1 organizational block. That's where we are going to write our program. As you can see, this is the main block. This is our general information, OB main, OB type, then language ladder. As you remember, we have indicated that we are going to use a ladder language, but also here, if you double click here, this is whereby you don't have this. You can add the organization block and select the language that we want to use. Again, you can add function block. Again, you can add, select the language. If you can notice, this our OB has option of 3, then our function block has option of 1, 2, 3, 4 languages. So these are the blocks that we are going to use, but for our purposes today we are going to use only OB1. You can add and have an OB2 when you're having complex systems. You can, not really complex systems, but a long program, you can have OB1, OB2, and function blocks will do that. But for now, it's just basic. Then now, this is the network where we are going to write our program. PLC, it's simple and straightforward. Again, as we indicated, revise your logic circuits. It will make easier for you to, because here we are dealing with zeros and one. Now, what is also important here, these are the basic instructions that we use to design our program. We have a normal open, a normally close, our assignment, which will be our output. This is the empty box, this is the open branch, this is the close branch. Okay, so these we are going to use. We can, these ones are put here because they are the most used one. You can also come here to instruction, basic instruction. You can go to timers and take your timers and also include them here, or you can go to counters, take your counters and also put it here. If you are someone that uses those, you can come here and select any of these instruction. And as you can see here, we have extended instruction and we have technologies. Again, we don't want to take you apart from what we have done here. We do have our PID. Then you press here, you come here. We're going to design a simple circuit. It's a pump. You want to start a motor or you want to switch on the pump. We'll have our start button as a normally open. You'll have our stop button as a normally close, and then we have our output as a motor or as a pump, whatever word you may decide to call. Now, what is important here, we have to address our input, so that when you are connecting your push buttons, your which in this case we can say those will be our sensors, you put them in the correct address so that they will communicate with the program. We have I 0.0, we say okay, then we must take this, rewrite or rename or retake. We call this start. We say change. we address this one I 0.1. okay, you take, right click, rename, we say stop, you change. Then we call this one I, and someone will ask why is saying I instead of Q. I will address that now. We say this is 1.0. We say okay, then we take, right click, we say this is a run, or we can say on. we can know that our motor is running or it's on. Let's put run, or our pump. Then this is like your basic, trying to give you a basic understanding. Now with this, you start, you close, because remember we said the power supplies, this is your power supply, 24 12 volt or 12 volt depending on your PLC. From this way going this direction, it's always go like this, from here to here, go here, not backward. So when you close here, press start. Remember, these are push button. When you press and release, it will be on. Once you release, it will be off. Now to cater for that, we design a latch circuit. Now our latch circuit, this will be our contact. So if this close, and this will close. Now what happens if I press start here? I will have the power moving from this direction, going this direction, and then when this one is on, this one will be on. Now once I release the start button, if this is on and this is on, the flow will be in this direction. So let us address this. We are going to say I1.0. It must be the same as this one because it has a contact for this one. And then as you can see, it has already picked up, that will be run. Now we are almost done here. This is where you can just run your circuit. However, we have not yet used Q, because at the end we need to write to run the motor, and our actuators are connected on our Q. We put this one and this one, and then we write here it's Q 0.0. okay, and then take, we will rename, we can call this pump on, so we know now this will be pump on. Now there are so many ways of doing this. Some people prefer to do everything on its network, like I've did here. I've put almost two, similar to like two auction in on a second network. Remove this one, maybe to make it easier for anyone who will be looking at this. You call this one I 1.0. okay, as you can see. Now what we are saying when the run LED is on, close these two contacts, and then when you close these two contacts here, what we are saying now, it must be connected to our Q. Q 0.0. You see, it's the same thing here. We can now delete this line. So what will happen when you close, when you press start, you energize this call. This call, it's a normally close. The power will go and switch and energize this one. When this one is high, it closes this one, and then our pump is on. If we delete this one, when this is energized, will close this one and this one, then our pump will run. Then if we want to stop while our pump running, we can press stop here. Then the circuit will stop, the motor will stop running, or we can put our timers and counters, and it will stop where you have selected your time. If you say it must run for how many seconds a minute, it will do that. So now what is important to do is, when you have designed the program, is you save. After you have saved the program, then you go to compile. We are not going to run now. I'm just showing you step how to. The next video will take us there. So as you can see here, I don't have an error here. Then now what you can do, you can come here for I'll make a typical example. Let's say we have connected now this this program to our physical PLC. Now you can come here, you download, and then after you download, you can then run this the circuits. But for us, in this case, you are going to press start simulation, but we are not going to do that now. What we are doing, we're just showing you how to navigate in this software. This is where you save your project. This we know you can open other projects here. These are your instruction. These are your basic, where you need your timers, your counters, and basic thing. Then here your technologies, where we'll need to use a program with a PID. We can also do that. So this is how you you can run this or you can design this program. Then what I would like us to do now, I just want you to show you now how to see your addresses. Here we have address. You have your start and you have your stop, you have your run. As you can see here, our start and stop, it's 0, 0.0, 0.1. Then our run, it's 1.0. It's the same as our program. Then our pump is on 0.0, that is Q. So now you can, now when you are connecting this physical, you can make sure that you connect according to the program. And also let me here also we do have a table, but this table will also show you on when we are designing a program and simulation and doing a simulation. So this is all for now. I hope this video will give you a little bit of understanding. If you have questions, feel free to use our platform that we use to ask any question. We are more than welcome. Your question are more than welcome and we are willing to answer all questions, so that when we meet next time, at least you have an understanding. As we have said before, we have ways of downloading this program on a website. I will share a link below, but you must register and it's a 21-day license. Thank you for your time.